All right, hi folks, this is Larry Mussolino. I wanted to record a short video here on week 3 in Math 101, and I wanted to go over graphing some common functions with you, and then do a typical example where you're asked to find what's called domain, range, and intercepts, and asymptotes. I should add asymptotes here. Okay, let's start out with some simple graphing. Let me come and graph an example here. Like let's say f of x equals x squared. Now, one way to sketch a graph is to make up your own XY table. So what I'm going to do is I'm going to create a table that looks like this. One column is X, one column is Y. Now for the X values, I'm going to pick any numbers I want. So here for X, I'm going to pick any values. It's up to you. Now, I'm going to pick numbers that are small and easy to work with. So I'm going to pick -3, -2, -1, 0, 1, 2, and 3. Remember, you can pick any values you want. All right, well, I want to figure out the corresponding y value for each one of these x's. Well, y is equal to x squared. So for the first row, y is going to be -3 squared. That's 9. Now, I'm going to make one more column here where I want to write down the x comma y summary. For the first row, the x value is -3. We just figured out the y value is 9. Let me do the same thing now for the second row. Here, x is -2, so y is -2 squared. Well, that's +4. So the second row, the point is going to be -2, 4. All right, I'm going to keep going. -1 squared is +1. So this row is going to be -1, 1. When x is 0, 0 squared just stays 0. So this is going to be 0, 0. And 1 squared is 1. 2 squared is 4. And 3 squared is 9. All right, so this row is a 1, 1. Here's a 2, 4. Here's a 3, 9. Now you can make as many rows in this table as you want. You can pick as many x values as you want. I'm going to leave it like this because what we're going to do now is we're going to plot these xy points on a graph. And once I do that, I'll connect the points with a smooth curve. And you can use this method to plot any of these graphs. So let me do it. Here is, let's go plot some xy points. Let's do -3, 9. Well, for that, you start here at the origin. You go horizontally -3. That means come back this way to -3. And then go vertically 9, which is up here somewhere. So that's the point, -3, 9. All right, we plotted that. Let's go plot -2, 4. I would go horizontally -2, +4. So that would put me about here. So this is -2, 4. And how about -1, 1? -1, 1 is about here. 0, 0 is right there. And then I'll plot the rest. 1, 1 is about here. 2, 4 is here. And 3, 9 is up here. Well, now I'm just going to connect these points with a smooth curve. It's going to do something like this. So this is the graph of f of x equals x squared. By the way, we call this a parabola. All right, well, it's good to know the shape of these curves. How about f of x equals the absolute value of x? Now I can make the same xy table to graph this, but as you work with these functions over and over, you kind of get a sense of what the shapes look like. So for the absolute value, this graph is going to be a V shape. It's going to look something like this. So that's the absolute value. How about f of x equals x to the third? Again, if you were to make up an xy table and plot points, you would see this graph looks something like this. It starts way down here, goes through 0, 0, and then goes up like that. All right, let's do one more. How about this last graph, which is the square root of x? And if I grab that, it's going to start here at 0, 0 and go up this way. All right, so it's good to know the general shapes of these four graphs because these are four, you might think of them as like four fundamental graphs that you're going to be working with. What if you forget the shape of any of these graphs? Well, you can create this XY table. Right, and if you plot a few points like this, you'll be able to see the general shape of these graphs. All right, let me go to my next example, which is finding the domain, range, asymptotes, and intercepts for this graph, square root of x minus 5. Now, I just mentioned that the square root function has a shape something like this. But what can happen is these graphs can get shifted around a bit. For example, this graph might get shifted to the right, or shifted to the left, or shifted up, or shifted down. So how about if we make up an XY table? So let's create an XY table here. All right, now, one thing I know is you cannot take the square root of a negative number. So when I go to pick X values here, remember for X, you can pick any numbers you want. I can't pick a number lower than 5, because if I pick, let's say 4, let's say I let X equal 4. Then the Y value is the square root of X minus 5. That would be the square root of 4 minus 5. That would be the square root of negative 1, but that's not allowed. Not allowed. So let me cross that out. I can't use X equal 4. Let me use instead X equal 5. All right, then Y is the square root of 5 minus 5. That's the square root of 0. That's 0. So 5 comma 0 is going to be a point on the line. So here I'm going to write down the XY points that we're going to be plotting here. All right, how about if I pick 6? Y is the square root of 6 minus 5. That's the square root of 1. That's 1. So 6 comma 1. All right, let me do a few more. I'm going to pick some numbers. In order to get the square root to work out to be a whole number, I'm going to try to avoid messy decimals here when I take square roots. So I'm going to pick 9 as my next number. Y is the square root of 9 minus 5. That's the square root of 4. That's 2. So 9 comma 2. I'm going to do one more. How about if I do 14, I think. 14, yep. So Y is the square root of 14 minus 5. That's the square root of 9. That's 3. So 14 comma 3. All right, that's enough. I'm going to go plot these. All right, so let's do 5 comma 0. That means go horizontally 5. Let's put 5 here. Go horizontally 5 and vertically 0. So that's the point 5 comma 0. 6 comma 1 would be here. 9 comma 2 would be over here somewhere. And 14 comma 3 would be here. So I could see this is going to be this familiar shape. But do you notice how this graph is shifted to the right compared to the original square root of x function? All right, well, now that we have the graph, let's answer some questions. It says, what's the domain? Well, the domain is really asking you, what are all the x values? Imagine you plotted all these points. Let me mark down some of these points. This was 5 comma 0. This was 6 comma 1, 9 comma 2, 14 comma 3. But remember, there's many points on this graph. The domain is the set of all the x values. Another way to think about domain, it's the horizontal span of the graph. So I'm asking myself, how far does this graph span along the x-axis, along the horizontal axis? Well, it looks like it's starting here at 5 and going all the way to the right. Well, if you go all the way to the right, that's infinity. Now, the number 5 is actually included in the domain because you notice that's a filled in circle there. So the way I'm going to write this is 5 comma infinity. The 5 is getting the square bracket, which indicates that the value 5 itself is part of the graph. Whenever you write infinity, you always put a parenthesis. By the way, this is called interval notation that we're writing here, interval notation. All right, let me go to the range. The range is asking you, what is the set of y values on this graph? For that, you're thinking about the vertical span. So how far is this graph going, up or down? Well, you know, when we did domain a minute ago, we noticed that the smallest x value was 5, and then the x values just kept getting bigger and bigger. So that's why we said the domain is 5 comma infinity. Let's do the same thing for the x values. It looks like they're starting at 0 and getting bigger and bigger. So the way I'm going to write this is 0 comma infinity. Another way to think about that is here is the vertical span of the graph. It starts here at y equals 0 and goes up to infinity. So this is the range. This on the x-axis was the domain. All right, what about intercepts? Well, intercept is asking you where is the graph crossing or intersecting the x or y axis? Well, the graph is crossing the x-axis here at the point 5 comma 0. So that's an x-intercept. But do you notice there's no y-intercept here? There's also no asymptotes for this graph. Let me explain what asymptotes are, but let me use a different graph for an asymptote discussion. All right, so let me clear the screen here for a second, and I'm just going to make up. So I want to give you more information about intercepts and asymptotes. All right, let me draw a graph here. And I'm going to make this graph do something kind of strange. It's going to do something like this, let's say. All right, this graph is going to go up like this and curve like this, let's say. All right, let me mark some of these lines. Let's say this point here is 5. So this vertical line is x equal 5. And let's say this point here is 7. So this line is y equals 7. I'm going to mark this point right here as 0 comma 10. And I'll mark this point as 8 comma 0, let's say. All right, let's find the intercepts. Well, the x-intercept is where the graph crosses the x-axis. Well, here's the x-axis. Where is the graph crossing the x-axis? Right here, this red dot. This red dot is where the graph is crossing or intercepting the x-axis. So the x-intercept here is 8 comma 0. What about the y-intercept? Well, here's the y-axis. It's this vertical axis. Where is the graph crossing the y-axis? Well, this blue dot right there, which I said is 0 comma 10. So that's the y-intercept. All right, what about asymptotes? Well, let's talk about a vertical asymptote. Well, a vertical asymptote is a vertical line that the graph gets closer and closer to but doesn't touch. Now, usually when you draw asymptotes on a graph, you use dashed lines. So this dashed line here we call a vertical asymptote. Because do you notice this part of the graph is getting closer and closer, but it's not going to touch that line. So the vertical asymptote here is this vertical line, which is labeled x equal 5. How about a horizontal asymptote? Well, that's a horizontal line that a graph gets closer and closer to. So if you notice this horizontal line right here, let me circle it maybe in green, this horizontal line right here, the graph is getting closer and closer to, but it's not going to touch. So the vertical asymptote here is y equals. Now remember, for something like this, you can graph this using Desmos. All right, because that would kind of show you what a graph looks like. Let me show that to you. In case you want to use Desmos, let me go to Desmos. Here it is. It's just desmos.com/calculator. And I'm going to type in y equals. Now I want the square root symbol. And if you click here on this keypad, notice down here at the very bottom is a square root symbol. And now I'm going to type in x minus 5. And if you notice, here is our graph that we had plotted by hand, but Desmos did it here for us. All right, so please use Desmos on the discussion boards. Use Desmos for any, any supplementary analysis you might want to do. All right, folks, hope this is helpful as you're working in week 3.